Here we have a pre-calculus math question on transformations of functions. Okay, let's go with the question. If point A of negative 3, 4 is on the graph of y equals to f of x, then the corresponding image point A prime on the graph of y equals to 1 half times f of 3x positive 12 negative 1 is. Here we have this point A of negative 3, 4 on the graph of the basic function y equals to f of x. After some transformations, the function is given over here. So we have to find the corresponding image point for this A of negative 3, 4. That is A prime on this transformed graph, transformed functions. Okay, so for that we need to understand the transformations applied over here. So before that, I have to make a little change in the given transformed function. That is, I'm going to factor 3 from this x and positive 12. If I factor 3 from this x positive 12, I'll be getting 3 times x positive 4 negative 1. So because usually the transformed function is written in the form y equals to a times f of b times x negative h positive k. So here a represents the vertical stretch or compression, and b represents horizontal stretch or compression, and this h represents horizontal translation, and this k represents a vertical translation. Okay, in our problem, at the place of a we have 1 half. Since the value of a is between 0 and 1, because this value 1 half is between 0 and 1, so there is a vertical compression by a factor of 2. So to apply this transformation on the basic function, so let's take the point negative 3, 4 on the basic function. To apply the vertical compression by a factor of 2, what I need to do is I have to multiply the y coordinate by this value 1 half. So then I'll be getting negative 3, so 4 times 1 half is just 2. Okay, now let's consider the value we have at the position of b. So here we have a value which is greater than 1. So this one represents horizontal compression by a factor of 3. So to apply horizontal compression by a factor of 3, so what I need to do is I have to multiply the x coordinate at each point on the basic function by 1/3. When I multiply this negative 3 by 1/3, I'll be getting negative 1. So this is the point I'm getting after vertical compression by a factor of 2 and horizontal compression by a factor of 3. Now I have to apply the horizontal translation of 4 units to the left, because whenever a number is added to x over here, so it represents a horizontal translation to the left. Since we have 4 over here, so here we have a horizontal translation of 4 units to the left. That is, the graph is shifted 4 units to the left. Since the graph is shifted 4 units to the left, I have to subtract 4 from the x coordinate. So when I subtract 4 from this x coordinate negative 1, that is negative 1, negative 4, which results negative 5. Okay, now I have to consider this value. That is, I consider value at the place of k. So this is vertical translation of 1 unit down, because it's a negative 1. Negative means it's down. So that is, the graph is shifted 1 unit down. So I have to subtract 1 from the y coordinate over here. So if I subtract 1 from this y coordinate 2, I'll be getting 1. So this is the final point I'm getting after all the transformations applied on the basic function. That is vertical compression by a factor of 2, horizontal compression by a factor of 3, horizontal translation of 4 units to the left, vertical translation of 1 unit down. So we get this final point negative 5, 1. So the correct answer choice for this question is option C.